You take this problem 49 of your textbook. What does the problem say? The problem says that uh, two particles of masses M1 and M2, that means there are two different masses, are joined by a light rod of length R, and the system rotates at an angular speed omega about an axis through the center of mass. It rotates through the center of mass. So let there be a light rod. I give it a dotted line because the rod is light, because the rod is not a part of the system of two masses, M1 and M2. And let us deliberately make these two of different size because there are masses are different. Let's say this is M1 and this is M2. And length of the rod is R. Length of the rod is R. Length of the rod, that is from here to here, thus length is R. Now looking at this mass, since this mass M1 is bigger, I have considered, so the center of mass will be towards the left of the line joining there. This is the center of mass. This is the center of mass. And both of them are rotating with an angular speed omega around an axis passing through the center of mass and perpendicular to the line joining them. Show that the angular momentum of the system. So you have to find out angular momentum of the system. Now, for finding angular momentum, we need to know the moment of inertia of these two masses. In order to find out the moment of inertia of these two masses, we need to find this distance. Say this distance is d, and this distance, of course, is then r minus d. So we need to find out d. The value of d we can find out from the very first chapter of your textbook where you have handled how to calculate the center of mass. And according to that formula, mass M1 multiplied by its distance d from the center of mass will be equal to mass M2 multiplied by its distance from the center of mass, which is r minus d. This r minus d is M2r minus M2d. So we bring the two parts with d on the one side. So this is M1d, this is M2d. If we take M2d to the left-hand side, we find M1 plus M2d is equal to M1 plus M2d is equal to M2r. From here, we find d is equal to M2 divided by M1 plus M2r. And similarly, so the other distance also we shall need to know, r minus d. R minus d will be M1 divided by M1 plus M2r. We have deducted this value of d, but in fact in your chapter of center of mass, this was used as a standard formula. the value of the distance d of the mass m1 from the center of mass. Now coming to the problem. Now coming to solve the problem of rotational dynamics, the moment of inertia I of mass m1. Moment of inertia of I of mass m1 is m1 d square, and the angular momentum of m1 is equal to moment of inertia multiplied by omega. So it was m1 d square. So this will be m1 d square omega. m1 d square omega. This is, from here we find moment of inertia of the, angular momentum of the mass m1 is equal to m1 multiplied by value of d we take from here is value of d we take from here is m2r divided by m1 plus m2, this whole thing square multiplied by omega. Similarly, moment of inertia of the mass m2 will be m2 r minus d whole square, m2 r minus d whole square, and angular momentum of the mass m2 is equal to m2 r minus d whole square, that multiplied by omega. From here we get angular momentum of the mass m2 is equal to m2 multiplied by m1r divided by m1 plus m2 whole square omega. So we have got two angular momentums of the two different masses. So total angular momentum is the summation of these two. So total angular momentum of the system is equal to angular momentum of the mass m1 plus angular momentum of the mass m2. If you add these two, what do you find? From the first one, we find m1 m2 square r square omega is the numerator. m1 m2 square r square omega in the numerator. In the denominator is m1 plus m2 whole square, plus the next one is also, next one is m2 m1 square. m2 m1 square r square omega divided by m1 plus m2 whole square. So this is equal to, we come here, this is equal to, we have, we will look at this, we have, if we take m1, if we take m1 m2 r square omega common, then in the numerator we shall have m1 plus m2. So this is equal to m1 m m2 r square omega is common. We shall have m1 plus m2 whole thing divided by m1 plus m2 whole square. This, of course, is equal to m1 m2 divided by m1 m2 divided m. This is equal to m1 m2 divided by m1 plus m2, because one of them will get divided, like this whole thing will get cancelled with the index. So m1 m2, so m1 m2 into r square omega, into r square omega, r square omega. This will be equal to, in the problem it is given, if mu is equal to m1 m2 divided by m1 plus m2. This is equal to mu r square omega. R square omega. Like here. The question said, show that the angular momentum of the system is L equal to mu r square omega, where mu is this. So this is proved. So this is proved. Now we shall go to the next question now.